This is objective 2H. I can build an equation from a word problem and solve it, and this is Miss Frost.
Okay, so our first problem here says a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. So we know no matter what, he's going to start off with $40,000. Okay, and then a commission, meaning he's going to get more money, so let's put in a plus. Commission of $300 for every machine he sells. So we know if he sells one machine, it's going to be $300. If he sells two machines, it would be 2 times $300. If he sells three machines, it would be 3 times $300. So we have to multiply. It's going to be 300 times the number of machines. So X is the number of machines he sells. Write an equation that shows the total amount of income the salesperson earns if he sells X machines a year. So we did that as we were reading this. So there we go. We already have our expression, just like we did in 2A. But we're going to take a little bit further now. To find the number of machines he needs to sell, find the number of machines he needs to sell to earn $100,000. So this tells us how much you would earn total. So we'll just put in equals 100,000. Now we can solve this two-step equation and find out how many machines he would have to sell to earn that amount of money. So we're going to minus 40,000 from both sides. They cancel out over here. We're left with 300x equals 60,000. And then we just need to divide by 300. So we took away his base salary from the amount that he wants to earn. And now we're going to divide by 300 to find out how many machines he has to sell. So they cancel out over here, and X equals 200 machines. So he's going to be very busy trying to sell all these machines. All right, let's try another problem. Shh. Okay, at a school play, children's tickets cost $3 and adult tickets cost $7. So we have a different situation here because we have two different types of tickets and they cost something different, so it's not going to be the same. So if we have our children's tickets, we can call that C, and we have our adults tickets and call that A. The total amount of money earned from tickets equals, there's a good word for us there, equals 210. Write a linear model that relates the number of children's tickets sold to the number of adult tickets sold. So we have, for each children's ticket, it's going to be $3. So this is 3 times C. And means plus, 7 for the adult tickets. So 7 times A equals 210. That's our linear model for this little story problem here. Now this can't be solved. If we have two different letters in an equation, we can't solve it. So let's find out what the next part is to this problem. Okay, in the ticket sales example above, how many children's tickets were sold if 24 adult tickets were sold? So now what we're going to do is we've found out how many adult tickets we have. It's 24. So we're actually going to plug in 24 and evaluate. So we have 3C. We still don't know how many children's tickets. Plus 7. We do know how many adult tickets. It's 24. Equals 210. I'm going to start by simplifying this side of the equation by doing 7 times 24. And I get 168, so it's 3C plus 168 equals 210. Now I just have a two-step equation to solve here. So I'm going to minus 168 from both sides. They cancel out over here, and I'm left with 3C equals 210 minus 168 is 42. And then our last step here, since our 3 is being multiplied by C, we're just going to divide by 3. and C equals 14. So we've discovered that there were 14 children's tickets sold. All right, that is it for this video. Thank you for watching.